So far we have used two normal forms already, the pseudo normal form and the BC normal form. You know to be confused by these different normal forms, right? So we have so many different normal forms already. Okay, so this page will provide you with some diagrams to help you clarify the relations among different normal forms. So we know that the pseudo normal form is more relaxed than the BC normal form. Therefore, the domain for the pseudo normal form will be larger because it is more relaxed. It can cover more relations than BC normal form. So the domain for the relations to be included in the pseudo normal form will be larger than the BC normal form. BC normal form is a subset of pseudo normal form. And we didn't introduce the false normal form in these lectures. False normal form is more strict. Therefore, the relations to be covered in the false normal form is even smaller than the BC normal form. It is a subset inside BC normal form as shown here, right? Normally, if we have more strict normal forms, the relations which we can cover in the normal forms will be less and less. In practice, we normally prefer to target for the pseudo normal form. We don't overdo the normal form requirements for the relations, because if we have strict requirements on the relations, then we have to decompose them into smaller relations. It will be a trade-off between the query efficiency versus the redundancy of the data storage. Okay, so we'll provide a summarization for different normalization normal forms we can use. The first normal form is usually one part of the word walk, and the second normal form is usually skipped. It's very old. The pseudo normal form is very important. We normally aim for this normal form in practice. BC normal form and false normal form, their trade-off will start here. And we prefer to have some dependency, preserving, and lossless decompositions. And fifth normal form, you can say you know this or you heard about this, but we don't use this in practice. And how about the current trends in database design? Normally, we know the object in database systems as well as in object-oriented database systems. We may permit some complex attributes, and the first normal form is not necessary actually in practice. So normally database system we use in our project is very small. However, in the real-world application or compliance, the data we store in their system is very big, and we have to use the data warehouse to help them for storing and managing their data. Normally, for data warehouse used in compliance, they have huge historical data systems, and then they set them or never update after creation. For large data in the data warehouse in compliance, the joins can be very expensive. Therefore, they don't prefer to use these normal forms, because if they decompose a relation into smaller relations, the joins is impossible or impractical. Therefore, they argue against normal forms for database or for data warehouse applications. And for a regular relational database system, we normally target for the pseudo normal form, and we can also aim for the BC normal form in applications. Okay, so this is the relational design section. I hope you can follow me in the section because this section is very complex. We have covered so many theoretical knowledge about this relational design. We include this function dependency, the keys, as well as the reasoning with the dependency and keys. We'll talk about different normal forms in the lectures. So please go over all the lectures and slides and textbooks to make sure you can follow the materials. And you can do your homework right now and to practice knowledge we learn from the lectures. Okay, so that's for the relational design. So right now, I think it's good time for you to prepare for the midterm now. We have several lectures on this Friday for you about the midterm. So you please check the Friday lecture very carefully on how to prepare for the midterms. Okay, so that's it for the relational design. I hope you enjoy this section.